The given question is two equal negative charges minus q are fixed at points 0, comma minus a and 0, comma a on y-axis. A positive charge plus q is released from rest at point 2a, comma 0 on the x-axis. The charge q will, so these are the options A, B, C and D. Okay, so let me draw the figure first. We have, let's say we are having axis like this. Okay, so on the x-axis, 2 minus q charges. So one is placed at 0, comma a. Okay, this is minus q charge. Another is also at 0, comma minus a. So this is minus q, and another charge plus q is placed at 2a, comma 0. Okay, so somewhat here, this is plus q charge. Let me draw this. Okay, so this is positive x-axis. This is positive y-axis. Okay, so now in the option 1, we have to check whether this charge q will execute simple harmonic motion about origin. Okay, so let's check about whether this charge is performing SHM or not. And before that, let's check what are the forces acting on this charge plus q. So let's check this distance between the y-axis and q charge be x. Okay, although its position is given as 2a, but first of all, for SHM, we have to check whether force is proportional to minus x or not. Okay, minus x, so let's say x. So if this is the primary condition for SHM, let's check that. So the force acting on charge q due to minus q charge will be an attractive force. Okay, in this direction it will be happening, right? So we can say a force Fr is acting like this, and similarly we will have a force due to minus q charge also, the same force, that will be Fr. Why same force? Because we note that electrostatic force is given as k q1 q2 divided by r square. Okay, where r is the distance between the charges q1 and q2. So here charges are same and the distance between them. Okay, let's name the points. This is a, b and c. So ab distance is equal to c distance. So r, q1 and q2 are same, thus the force between the charges capital Q and minus q will be same. Further, let's resolve this force components in two parts. We will have, one will be, let this angle be theta. If this angle is theta, this angle will also be theta, and this will be Fr sine theta, right? And in the downward direction we will have, due to minus q charge, this will be same force but in the negative direction. This will be Fr sine theta. Moreover, this force Fr, its horizontal component will be, okay, so the horizontal component would be like this. Okay, so this will be Fr cos theta, and due to the this Fr below 1, it will be same. Okay, same force will be acting, that is again Fr cos theta. So this Fr sin theta, the vertical components will cancel out each other as they are in opposite direction. So the net force acting on the plus q charge would be given as, let's say, F net, and this will be equals to 2 times of Fr cos theta, and this will be occurring in the direction of minus I cap, okay, towards the origin, and this will be given as 2 into the magnitude of Fr will be what, k into q1, that is capital Q, into q2, that is small q, divided by distance whole square. Okay, so distance between capital Q and minus q is AB. So this is AB whole square multiplied by the value of cos theta would be, cos theta will be given as this x over AB, right? X divided by AB. Further, on solving this, we will get 2 into k q into q. Okay, AB we can find. See, this distance is a, right? So AB will be equals to under the root a square plus x square whole square multiply by x over under the root a square plus x square. From here we can write the value of F net equal to 2 times k q into x divided by a square plus x square whole to the power 3 by 2. Okay, so this will be the magnitude of the F net force. So from here we can see that F net is not directly proportional to x, okay, which is the prime condition for SHM. So here x in the numerator also and in the denominator also, hence this is not a SHM. Okay, so from the given option, option A will be wrong because it's saying that it's executing SHM. So option A is wrong, option B will be wrong as it is saying move to infinity. Now let's check other options. We will have, see, this plus q charge would be moving towards the origin. So when the charge plus q will reach the origin, the net force on the charge q will be zero because minus q and minus q both will be exerting the same force in opposite direction. So it will cancel out and net force becomes zero at the origin. But at origin, this plus q charge will gain some velocity and its velocity will be maximum at the origin. So due to momentum, this plus q charge will move further, okay, in the negative x direction, and it will reach up to a certain distance that will be again equals to 2a, okay, after which the force acting will reverse in this direction and the velocity of this charge becomes zero, so such that this charge will move again in the opposite direction. So in this way it will be performing an oscillatory motion about the origin. So we can say that from the given options, option C would be the correct answer. Okay, because the charge q will perform an oscillatory motion but not SHM. Okay, and this will be about origin. Okay, if I take origin as O, so about origin it will perform a oscillatory motion. Thank you.
Hello, we are given the question and the question says for A equals to 0, the value of D, maximum value of P is shown in the figure is how much? So value of D is how much? The maximum value of the density, right? So let us take a spherical shell here, first of all, and let us assume that the total charge simply given by density over the volume, right? So we will take a shell from the center at a distance x and the thickness is dx, let's say. So the charge on that is equal to 4 pi x square rho x into dx. That would be the amount of total charge on that shell of thickness dx. So integrating from 0 to r, we would get the total amount of charge, that is 4 pi x square rho of x dx. Now, if the density distribution here is linearly, right, is given in the figure for A equals to 0, here A equals to 0, then the density would linearly decrease from D at R equals to 0 to R equal to R. The mathematical equation would be given by rho of x equals minus D by R into x plus D. Right? So putting this in the above equation, we get Q equals 4 pi D by R, integration from 0 to R, x square into minus x plus D. Instead of here D, we would have R minus x plus R into dx. Or we can write 4 pi D by R. When we integrate this value, it would be minus R power 4 by 4 plus R power 4 by 3. So that is equal to 4 pi dr cube by 12. That is pi dr cube by 3. Right? So given that as given Q is equal to ZE, so ZE is equal to pi dr cube by 3, which implies that D is equal to 3ZE by pi r cube. So our answer would be 3ZE by pi r cube. That is option B. Thank you.
इस क्वेश्चन में हमें एक ग्राफ दिया गया है रो ऑफ आर क्या होता है? रो ऑफ आर होता है वॉल्यूम चार्ज डेंसिटी, वॉल्यूम चार्ज डेंसिटी, ओके। एंड आर, आर जनरली क्या होता है, डिस्टेंस, डिस्टेंस एट विच वी आर मेजरिंग इलेक्ट्रिक फील्ड, विच वी आर मेजरिंग इलेक्ट्रिक फील्ड, ओके। तो इन दोनों का ग्राफ दिया गया है एंड हमसे बोल रहा है वो कि जो इलेक्ट्रिक फील्ड है इस ऑब्जर्व टू बी लीनियरली डिपेंडेंट ऑन आर, तो जो इलेक्ट्रिक फील्ड है वो आर के डायरेक्टली प्रोपोर्शनल है। दिस इम्प्लाइज ए की वैल्यू अपनी क्या होगी, तो ई इज डायरेक्टली प्रोपोर्शनल टू आर है। और जो ई होती है इलेक्ट्रिक फील्ड वो न्यूक्लियस के अंदर कैसे लिखी जाएगी, ये न्यूक्लियस है, इसके सेंटर पर मान लिया जो ये चार्ज कंटेन कर रहा है वो क्यू है, ओके। ये क्यू चार्ज सेंटर पर होगा, जरूरी नहीं है क्योंकि जो वॉल्यूम चार्ज डेंसिटी है वो वेरी कर रही है, तो ये यूनिफॉर्मली डिस्ट्रीब्यूटेड होगा। तो जो क्यू चार्ज होगा, क्यू चार्ज को हम कैसे लिख सकते हैं, इसके लिए सिंस इसकी हमें क्या दी गई है, वॉल्यूम चार्ज डेंसिटी रो ऑफ आर दिया गया है, तो हम क्या कर लें, एक आर डिस्टेंस पर यहाँ से एक डी आर थिकनेस का सरफेस सिलेक्ट कर लेते हैं, ओके। तो ये आर डिस्टेंस पर मैंने डी आर थिकनेस का एक सरफेस सेलेक्ट कर लिया, तो इसका सरफेस एरिया कितना हो जाएगा, 4 पाई आर स्क्वायर, ओके। थिकनेस डी आर है तो वॉल्यूम कितनी हो जाएगी, 4 पाई आर स्क्वायर डी आर। एंड वॉल्यूम चार्ज डेंसिटी रो ऑफ आर दी गई है, तो जो चार्ज कंटेन करेगा न्यूक्लियस वो कितना मिल जाएगा हमें, 4 पाई आर स्क्वायर डी आर रो ऑफ आर। तो ये क्या है, डी क्यू चार्ज जो इससे कंटेंट होगा। पूरे स्फीयर के निकालने के लिए हम क्या कर देंगे, इसको इंटीग्रेट कर देंगे। आर कहाँ से कहाँ तक जाएगा, जीरो से कैपिटल आर तक जो रेडियस है इसकी, जीरो टू कैपिटल आर, ये हो जाएगा 4 पाई आर स्क्वायर डी आर इंटू रो ऑफ आर, ओके। तो जो यहाँ पे ये आ गया अपना चार्ज, ओके, इसको हम नोट कर लेते हैं, यहाँ पे गौर करना आप लोग। इसके बाद जो इलेक्ट्रिक फील्ड होती है, आप सभी जानते हैं कि जो इलेक्ट्रिक फील्ड होती है यदि क्यू चार्ज के ड्यू टू हमें आर डिस्टेंस पर फाइंड करनी है तो होती है के क्यू आई आर स्क्वायर, ओके ना। अब वो क्या बोल रहा है, अपनी जो इलेक्ट्रिक फील्ड है वो आर के डायरेक्टली प्रोपोर्शनल है, जो इलेक्ट्रिक फील्ड है वो आर के डायरेक्टली प्रोपोर्शनल है, मतलब अपना जो क्यू होना चाहिए वो किसके डायरेक्टली प्रोपोर्शनल होना चाहिए, आर क्यूब के। तभी तो आर क्यूब से आर स्क्वायर कैंसिल हो जाएगा, आर बचेगा। तो अपना जो यहाँ से क्यू आ जाएगा, ये आर क्यूब कब आएगा, जब रो ऑफ आर कांस्टेंट रहेगा। ये आर क्यूब कब आएगा, क्योंकि आर स्क्वायर का इंटीग्रेशन हो जाएगा तो ये आर क्यूब बाई 3 आ जाएगा, कब, जब रो ऑफ आर कांस्टेंट रहेगा, रो ऑफ आर इज इक्वल टू कांस्टेंट, ठीक है। और कहाँ तक रहेगा, सिंस इस स्फीयर की हमने रेडियस क्या मानी थी, कैपिटल आर, टोटल रेडियस हमने मानी थी कैपिटल आर, तो जो रो ऑफ आर है वो कांस्टेंट रहना चाहिए कैपिटल आर तक, गाइस समझ रहे हो आप। तो इसके बाद हमें ग्राफ में दिया गया था कि रो ऑफ आर एस कांस्टेंट है कहाँ तक है, ए तक, तो ए की वैल्यू यहाँ से क्या हो जाएगी, कैपिटल आर। तो दिस विल बी अवर आंसर, तो कौन सा ऑप्शन करेक्ट हो जाएगा, ऑप्शन सी इज अवर करेक्ट। थैंक यू।
The given question is four charges Q1, Q2, Q3 and Q4 of same magnitude are fixed along the x-axis at x equals to minus 2a, minus a, plus a and plus 2a respectively. Okay, so as we can see from the figure, we are having four charges Q1, Q2, Q3 and Q4 of same magnitude and are placed at minus 2a, minus a, plus a and plus 2a on the x-axis. A positive charge Q is placed on the positive y-axis at a distance b greater than 0. Four options of signs of these charges are given in the list 1. The direction of forces on the charge q is given in list 2. We have to match list 1 and list 2 and select the correct answer using the code given below in the list. So in the list 1 we are having the signs of the charges. Okay, so it is q1, q2, q3 and q4 all are positive, and similarly in list 2 we are having the direction of the net force acting on this small charge q. Okay, so this is positive x, positive minus x, plus y and minus y axis. So let's go one by one. We have in p all the four charges q1, q2, q3 and q4 are being positive in nature. So now also we are given that this small q charge is positive, so let me draw this. This is plus q charge. Okay, it is being placed here, and we are having this are this is as the x-axis. Okay, and four charges are being placed. Okay, so this is q2, this is q1, this is q3 and this is q4. Okay, so this is Q4 here. So see now all the four charges are positive in first part, so they will exert a force on positive Q also, like they will repel each other. Okay, so if I draw the force acting on the plus Q charge, so we have here due to Q1 on plus Q charge there will be a repulsive force. Okay, let me remove it from here and then I'm just drawing the forces. So from Q1 there will be a, let's say, F1 force acting. Okay, due to Q2 there will be a F2 force will act in this direction. Due to Q3 there will be a F3 force acting in this direction. This is F3, and due to Q4 we will have a force F4 acting. Okay, and these all four will be repulsive in nature. So now I have drawn F2 and F3 of greater magnitude because Q2 and Q3 are placed near to the positive Q charge. Okay, so as the distance is less, so the magnitude of force will be more. Now see, the forces F1 and F4 will be having same magnitude, but their direction are in shown in the figure. So if I draw the components of F1 and F4, so their x component will cancel out each other, right? And similarly for F2 and F3, their component in the horizontal direction will cancel out each other due to symmetricity. And the component of the force of the net force will be acting only in the y-axis, right? So this will be the direction of the F net force. So due to symmetricity, this net force will be acting in the y direction only. So we can say that for P option we are having plus y. So this is for P option. Next we have, let me clear the figure. Okay, so for the next part we are having Q1 and Q2 are being in positive in nature, Q3 and Q4 are being negative in nature. So we have Q1 and Q2 are positive, so force will be similar due to them in the previous case. This is F2 and this is F1. But as Q3 and Q4 are negative, they will tend to attract this small Q charge towards themselves. So Q3 will attract with some force, this is F3, and Q4 will attract with some force, this is F4. So again, as we can see from the figure, the y component of these forces of F1 and F4 will cancel out each other, and similarly the y component of F2 and F3 force will cancel out each other, and the net force will be acting in the positive x direction only, okay, due to the symmetricity of the forces. So for Q part we are having the answer as positive x. So this is for the Q part. Okay, so let me rub it again and make it for next part. So for the part C, we are having Q1 and Q4 as positive and Q3 and Q2 and Q3 as negative. So this Q1 and Q4 will apply a repulsive force on the small q charge. So it will be like this only. Q1 will be rep repelling the small charge Q by a force F1. Okay. Q2 will be attracting. Q2 will be attracting it. Okay, see here the force F1 will be of smaller magnitude. Okay, this will be of smaller magnitude. This is F1. This is F2, and Q3 is again negative, so Q3 will be like this, and Q4 is positive, so it will repel. Okay, like this. So here see, we can see the x component of F1 and F4 will cancel out each other, and there will be a net force due to F1 and F4 in the positive y direction. And for F2 and F3, their x component will also cancel out each other, and the net force of F2 and F3 will be acting in the downward direction. So now we can see that these two net forces we are having the maximum force acting in the negative y direction. So resultant of these two forces will be acting in the downward direction only. Okay, so net force will be in this direction. So we can say that for part R we are having minus y axis. Okay, so this is minus y, this is our part, and for the last part it is this. Okay, so this was the plus q charge here placed here, and now we are having in the part S q1 and q3 are positive and q2 and q4 are negative. So q1 is positive, so we will have a force F1 in this direction. Q3 is positive, so Q3 is positive, so it will repel in this direction. This is F3. Q2 is negative, so it will attract the plus Q charge in this direction with the force F2, and Q4 is negative, so Q4 will attract like this, okay, with the force F4. Now again, due to the symmetricity, the components of F1 and F4 in the y direction will cancel out each other, and we will have a resultant in the x direction due to F1 and F4, and similarly we will have a resultant force due to F2 and F3 in the negative x direction, okay, with a greater magnitude. And now again we can see from the figure that this resultant, the maximum is in negative x direction, so the resultant of these two vectors will be in the negative x direction. So we can say for part S we will be having the resultant force acting in negative x direction. So the correct option will be P3 Q1 R4 and S2. And from the given options A, B, C and D, option A will be the correct answer. Thank you.
इन दिस क्वेश्चन हमें दे रखा है कि लेट E1R, E2R and E3R be the respective electric field at a distance r from a point charge q, an infinitely long wire, okay, with constant linear charge density lambda and infinite plane with uniform surface charge density sigma, if E1 r naught is equal to E2 r naught is equal to E3 r naught, okay, at a given distance r naught, then हमें ये चार ऑप्शन दिया हुआ है, इसको कौन सा इसमें करेक्ट होगा ये हमें फाइंड आउट करना है। तो देखते हैं कि फर्स्ट वाला क्या दिया है। हमें दिया है कि एक इनफाइनाइटली लॉन्ग वायर है, ठीक है। तो हम यहाँ पे क्या करते हैं कि एक इनफाइनाइटली लॉन्ग सपोज करते हैं कि ये वायर है, ओके। तो इसकी वजह से कुछ डिस्टेंस पे जो इलेक्ट्रिक फील्ड होगा वो क्या होगा। फर्स्ट ऑफ ऑल तो हमें एक पॉइंट चार्ज दिया हुआ है, ठीक है। उसके बाद दूसरा दिया है वो क्या दिया है, वो इनफाइनाइट वायर दिया हुआ है। तो पहले तो हम बात करते हैं एक पॉइंट चार्ज की, ठीक है। एक पॉइंट चार्ज क्यों है, ओके। इसकी वजह से आर नॉट डिस्टेंस पे जो इलेक्ट्रिक फील्ड होता है वो क्या होता है, ई वन ले लेते हैं इसको। ई1 इज इक्वल टू 1/4 पाई एप्सिलॉन नॉट क्यू बाई आर नॉट स्क्वायर, ठीक है। अब इसके बाद दूसरा क्या दिया है, दूसरा दिया है इनफाइनाइटली लॉन्ग वायर। तो यहाँ पे मैं इनफाइनाइटली लॉन्ग वायर सपोज करता हूँ कि इस तरीके से ये क्या है, पॉजिटिवली चार्ज है, ठीक है। तो इसकी वजह से आर नॉट डिस्टेंस पे जो इलेक्ट्रिक फील्ड होगा वो क्या होगा, ये होता है E2 इज इक्वल टू 1/4 पाई एप्सिलॉन नॉट, यहाँ पे होता है 2 लैम्डा बाई आर नॉट, ठीक है। और तीसरा में दिया है कि ये प्लेन शीट है, ठीक है, जिसका चार्ज डेंसिटी सिग्मा है। तो हम क्या करेंगे, यहाँ पे एक प्लेन शीट बना लेंगे, ओके। ये कुछ इस तरीके का प्लेन शीट है। तो यहाँ पे क्या है, ये पॉजिटिवली चार्ज है। तो इसकी वजह से जो आर नॉट डिस्टेंस पे फील्ड होगा वो क्या होता है, वो होता है E3 इज इक्वल टू सिग्मा बाई 2 एप्सिलॉन नॉट, ठीक है। अब ऑप्शन फर्स्ट देखते हैं कि क्या दिया है, सॉरी ये देखते हैं कंडीशन क्या दिया है। E1 एट आर नॉट इज इक्वल टू E2 एट आर नॉट दिया है, ठीक है। तो E1 क्या है, 1/4 पाई एप्सिलॉन नॉट क्यू बाई आर नॉट स्क्वायर इज इक्वल टू E2 क्या है, 1/4 पाई एप्सिलॉन नॉट टू लैम्डा बाई आर नॉट। ठीक है, तो यहाँ से हमको क्या मिलेगा, 1/4 पाई एप्सिलॉन से 1/4 पाई एप्सिलॉन कैंसिल हो जाएगा, एक आर नॉट से एक ये आर नॉट कैंसिल होगा, तो यहाँ क्या बचेगा, Q इज इक्वल टू 2 लैम्डा आर नॉट। ओके, तो यहाँ पे Q इज इक्वल टू क्या है, 4 सिग्मा पाई आर नॉट स्क्वायर। तो ये ऑप्शन क्या हो गया, गलत हो गया। ठीक है, ये ऑप्शन क्या हो गया, गलत हो गया। अब दूसरा कंडीशन इसमें हम अप्लाई करते हैं। ठीक है, यहाँ पे क्या दिया है कि E2 R0 इज इक्वल टू E3 R0 दे रखा है। तो यहाँ पे हमारे पास E2 क्या है, E2 है 1/4 पाई एप्सिलॉन नॉट 2 लैम्डा बाई R0 इज इक्वल टू E3 क्या है, सिग्मा बाई 2 एप्सिलॉन नॉट। यहाँ से हमें क्या मिलेगा, यहाँ से मिलेगा, इसको जब कट करेंगे तो हमें मिलेगा R0 इज इक्वल टू R0 इज इक्वल टू, यहाँ पे R0 को ले जाते हैं तो ये क्या हो जाएगा, R0 इज इक्वल टू 2 एप्सिलॉन नॉट डिवाइडेड बाई सिग्मा इंटू 1/4 पाई एप्सिलॉन नॉट 2 लैम्डा। ठीक है, तो यहाँ से देखिए, यहाँ से एप्सिलॉन कैंसिल, ये 2 × 2 क्या होगा 4 डिवाइडेड बाई 4, ये भी कैंसिल, तो ये R0 इज इक्वल टू क्या हो जाएगा, ये हो जाएगा लैम्डा डिवाइडेड बाई पाई सिग्मा। ठीक है, तो हमारे पास क्या है, लैम्डा डिवाइडेड बाई 2 पाई सिग्मा R0 की वैल्यू। तो ये भी ऑप्शन क्या हुआ, ये भी गलत हुआ। ठीक है, अब हम क्या करते हैं कि ऑप्शन थर्ड देखते हैं, सी देखते हैं। इसमें क्या दिया है, E1 एट R0/2 इज इक्वल टू 2 टाइम E2 एट R0/2। तो E1 की वैल्यू क्या है, पॉइंट चार्ज की वजह से इलेक्ट्रिक फील्ड क्या होगा, पॉइंट चार्ज की वजह से इलेक्ट्रिक फील्ड जो होगा वो होगा 1/4 पाई एप्सिलॉन नॉट Q/R0 स्क्वायर, और ये ऊपर चला जाएगा 2 का स्क्वायर, तो ये 4 हो जाएगा। ठीक है, ये इक्वेशन फर्स्ट मैं मान लेता हूँ और E2 की वैल्यू निकालता हूँ। E2 की वैल्यू मैंने पहले से निकाल लिया है, लेकिन R0/2 पे नहीं निकाला है, तो ये निकालता हूँ। ये हो जाएगा 1/4 पाई एप्सिलॉन नॉट 2 लैम्डा डिवाइडेड बाई R0/2 था, तो ये ऊपर चला जाएगा, ये हो जाएगा 1/4 पाई एप्सिलॉन नॉट 4 लैम्डा बाई, यहाँ पे क्या हो जाएगा, यहाँ पे हो जाएगा R0। ओके, और यहाँ पे 2 से मल्टीप्लाई करना है। ओके, तो ये हो जाएगा 8 लैम्डा डिवाइडेड बाई 4 पाई एप्सिलॉन नॉट R0। ओके, इसको मैं इक्वेशन 2 मान लेता हूँ। ठीक है, अब इक्वेशन फर्स्ट में देखिए, यहाँ पे Q है, यहाँ पे लैम्डा है, तो यहाँ पे मैं लैम्डा की वैल्यू पुट कर देता हूँ। ठीक है, या यहाँ पे मैं Q की वैल्यू पुट कर देता हूँ। तो देखिए, यहाँ पे मैं Q की वैल्यू पुट कर देता हूँ। Q की वैल्यू मैंने पहले ही फाइंड आउट कर रखा है। Q इज इक्वल टू क्या है, 2 लैम्डा R0 है। ओके, तो यहाँ पे जब मैं पुट करूँगा तो ये क्या हो जाएगा, 1/4 पाई एप्सिलॉन नॉट, ये हो जाएगा 4 × 2 लैम्डा R0 डिवाइडेड बाई R0 स्क्वायर। तो यहाँ से R0 से R0 कैंसिल हो जाएगा, और ये हो जाएगा 8 लैम्डा डिवाइडेड बाई 4 पाई, क्या हो जाएगा, एप्सिलॉन नॉट R0। ओके, तो ये देखिए, ये पार्ट है हमारा E1 एट R0/2, और ये पार्ट है E2 एट R0/2 मल्टीप्लाई बाई 2। ये दोनों क्या है, दोनों इक्वल है। ठीक है, तो हमारा ऑप्शन क्या होगा, हमारा ऑप्शन जो होगा वो सी करेक्ट है। ठीक है, सी क्या है, करेक्ट ऑप्शन है। ओके, इसी तरीके से जब आप E2 एट R0/2 और E3 एट R0/2 निकालेंगे तो ये क्या आ जाएगा, अनइक्वल आ जाएगा। ठीक है ना, आप इसको इजीली कर सकते हैं। तो ये ऑप्शन क्या होगा, ऑप्शन सी हमारा करेक्ट ऑप्शन होगा। ओके,
Hello everyone, let us start with our question. In this question, what is given that an infinitely long solid cylinder radius is given as to be capital R with a uniform volume charge density is given as to be rho. Now it has a spherical cavity of radius capital R by 2 with its center on the axis of the cylinder as shown in this figure. So this is a spherical cavity of radius R by 2. Now the magnitude of electric field at the point P, which is at a distance of 2r from the axis of the cylinder. We need to calculate what is the value of the electric field at this point. It is given as by the expression 2 small r capital. Basically this is 2 rho. Here it is rho. Okay, rho r by 16k epsilon, and we need to find what is the value of k. Now this distance is given as to be 2r. Now how can we treat this problem? So basically we will be treating this problem in such a way that we will be taking a this is, let's assume that this is our cylinder. Let's assume that this is our cylinder. We can just give it like this. This is our cylinder, infinitely cylinder. So now what we will do, we will place a sphere of charge density or of charge, this which would be negative, or it would have a negative charge density. So if this sigma is the charge density on this cylinder, so here the charge density is what, minus of sigma, so that it could counter the effect of this, and it could provide us with the cavity at its center. So we will be doing like this. Okay, so that means we need to calculate electric field would be due to what, electric field at this point P would be due to our cylinder, and electric field we can say that it would be minus due to sphere. Why? Because the direction would be different. Here the charge is positive and we have taken the charge on cavity to be negative, so that we could get a cavity here. Okay, we have just assumed that there would be a solid sphere which would place here, but its charge density would be just negative times. Okay, now how is electric field given for a cylinder? So at any point outside this cylinder surface, electric field is given as 2 into k into lambda divided by distance. Okay, now here 2 is constant, k is 1 by 4 pi epsilon. Now what is the value of this unit charge density? Okay, now linear charge density. Now this is given as to be volume charge density, and we need to find what is the value of linear charge density. So lambda could be written as, we can just write lambda would be written as volume charge density into area. Why? Because rho is written as what, rho is what, charge per unit volume, and if we multiply it by area, we would be getting lambda. Why? Because volume would be area into length, so area and area would get cancelled out, and finally we would be getting q by l, which is lambda. So we can just write 2k, and then we can just multiply rho with the area. Which area? Cross sectional area, pi r square, and divided by what is the distance from here to here, it is 2r. So this 2 would be gone, 1 power would be gone, for r it would be gone, and it would be we can just write pi k rho into r. This is due to cylinder. Now what is the electric field due to sphere? So we can just calculate electric field due to sphere. If we could calculate electric field due to sphere is what, it is given as k into charge divided by the distance. Distance is 2r, so we can just write distance is this. Now what is the value of charge? So if sigma is the volume charge density, so total charge would be, we can just write, so it would be volume charge density multiplied by the volume, which is equals to 4 by 3 then pi into r cube, and then divided by 2 r square. It would be like this. Okay, so this factor would turn out to be, if we calculate this one, so it would turn out to be, we can just cancel this factor. Sorry, let us check what is the radius of this sphere. Let us check what is the radius value. So radius is r by 2 for this sphere, so we need to write the value r by 2 here, not r cube. So because the charge would be just at a distance of r by 2, so it is, we should write r divided by 2 here. Now this is okay. Now what would happen? This 2 would cancel this 4, and what we are left with, I'm just writing, so there would be k which would left, there is rho which is left, pi would left. Okay, now just adjust this factor. So here it is 3, and here it would be 2 square. 2 square means 4, so 4 into 3, that means 24. So in the denominator we would be having a 24. Now where is this 4 gone? So 4 is gone from this denominator. Okay, now what are just we are left with 4 by 3 pi into, this is r cube, so we need to write r cube, so it would be r cube. Then it would be 2 cube is 8, and 8 into 3, that means 24. So r square would be gone, and there would be 1 power of r that would be left. Okay, now this is the thing. Now we need to find electric field. So electric field would be basically the difference of these two quantities. So we know that here it is k pi rho, so we just write here pi k rho r, minus we just write here pi k rho r by 24. So what we can take? We can take k pi k rho r to be common, and then it would be 1 minus 1 by 24. So it would be 23 by 24. Okay, now we need to compare, we need to calculate the value of k. So we can just put this equals to 23 rho r divided by 16k epsilon. So we can just put this value equals to, so we can just put this value is equals to what? We can 23, we can just put 23. So it would be 23 by 16, and then it was rho capital R divided by k epsilon. And now what is our value? Our value is pi. Then k value would be 1 by 4 pi epsilon, because here epsilon is coming, and then it would be rho, it is rho, and this is r into 23 by 24. So we should not confuse with this k and this k. So we can just call this as k dash, because this is 1 pi 4 pi epsilon. So what are the factor which is gone? So this 23 is gone, this 23, rho r is gone, pi is also gone. So what we are left with? We are just left with 16, then here 4, then here it would be 24. So we can just cancel this 4, 1, and then it would be 4 times, and then we can 4 cancel here, and there k would be 6, which value would be coming. So our k value would be 6 in this expression. So hope you have understood this explanation. Thank you. Hello everyone. Let us start with our question. In this question, what is given? A solid sphere of radius capital R and charge capital Q is distributed in its volume with a charge density is given as to be rho k r to the power a, where k and a are given to be constant and r is the distance from its center. Now we are given with that electric field at small r equals to r by 2, that is half of the radius, is 1 divided by 8 times the electric field at small r equals to capital R, and we need to find what is the value of a. So what we are given with? We are given with that electric field at small r is equals to r by 2 is 1 by 8 of electric field at a distance of r, that is at the radius. We need to find these values. So how are electric field given? We know the electric field formula. We can just write, or we can just first of all draw our diagram. So for example, this is our sphere on which charge is distributed, and sigma rho is given as to be k a to the r to the power a. Sorry, it is r to the power a. Okay, we can just write r to the power a. Okay, now on the surface, if we need to find the value of electric field, so what we need to find? We need to find charge which is enclosed by this surface. That means charge enclosed by the radius. Now if you wanted to find electric field at small r by 2, for example, this is the center, and let's call this is the distance r by 2, or this is the sphere at r by 2. So in this condition, we need to find what is the charge inside this part. Okay, so first of all, we should write how our charge written. Okay, q value, we know that q value could be written as integration of what? Rho into elemental volume. So it would be for a sphere, it is equals to 4 pi r square into d into r. Now what is the value of rho? Rho value is k r to the power a. So we can take this k common because it is a constant. So we can just write 4 pi k, and then there would be just r to the power a, then r to the power a plus into r to the power 2. So it would be r to the power a plus 2 into dr. Okay, now if we want to find the total charge, that means from 0 to r, that means total charge q would be equals to what? This would be equals to, we just change our limit to 0 to capital R. Okay, then it would be r to the power a plus 2 into dr. Now what we can do? We can just integrate it. So it would be 4 pi k. Now what is the integration of a plus 2? So integration of a plus 2 would be a plus 3 divided by a plus 3, r to the power a plus 3 divided by a plus 3. So this is divided by a plus 3. Okay, now what is the limit? So we need to put small r as capital R. So we can just directly put to save our step. So it would be capital R to the power a plus 3. This is the charge, because this lower limit is 0. So there is no need to subtract lower limit. Now this is the charge. Now what would be the charge q? We can just write here small q. So small q value would be what? This is small q at r by 2. So we can just integrate this with a limit of what? With a limit of 0 to r divided by 2, r to the power a plus 2 into dr. Now if we integrate this, what would be our integration? This would be constant, and in the denominator we would be having a plus 3 similar to this. So we can just write a plus 3. Now what is the value of r? So r value is capital R divided by 2. So we can just write capital R divided by 2. And what would be the power? So here power would be A plus 3. Okay, this would be the case. Now, what is given to us? This is the condition which is given to us. Now we can find the value of electric field. Electric field at a distance of r by 2 would be equals to what? We know that electric field at a distance of r by 2 would be equals to 1 by 4 pi epsilon. What is the charge? Charge value is what? 4 pi k into r divided by 2. This is the value of the charge, this whole expression. A plus 3 divided by what? A plus 3. So this is the value of charge. So electric field is written as 1 by 4 pi epsilon, then q divided by r square. So what is the distance? We are calculating this value for r by 2. So we just divide it by what? R divided by 2 square. We can just write it like this. Now this value is 1 by 8 of electric field at the surface. So it would be 1 by 4 pi epsilon. We can just write it like this, similar to this. Now what is the value of charge at the surface? It is the total charge, whose value is 4 pi k, then r to the power a plus 3, then divided by what? A plus 3. A plus 3. Okay, now we also need to write the distance, and distance would be equals to what? For the surface it is equals to r square, so it would be r square. We can just write it r square here. Okay, now how can we write? 1 by 4 pi epsilon, 1 by 4 pi epsilon is gone, 4 pi k is gone, 4 pi k is gone, a plus 3 is gone, a plus 3 is gone. So this value, this we can write it as like this. R by 2, it is the same, r by 2, this and this is same, so we can just adjust the power. So a plus 2 minus 2, so it would be a plus 1. Now this is 1 by 8, so we can just write it as 1 divided by 2 raised to the power 3, and we can write this as this is capital R, a plus 3, and then power would be minus 2, so we can just write it as this, like this. Okay, now here r to the power a plus 1, here r to the power a plus 1, so r to the power would be gone, so here it would be just 2 to the power a plus 1 would be equals to 1 divided by 2 raised to the power 3. So if we compare the powers, we can say that a plus 1 value is equals to 3, which implies that a value is equals to what? A value would be equals to 2. So this is what we need to find. So we need to find the value of a. So a value is equals to 2 for our case in this condition. So hope you have understood this explanation. Thank you.
In this problem, we have given that 5-point charges, each of value plus q coulomb, are placed on 5 vertices of a regular hexagon of side L meters. The magnitude of the force on the point charge of value minus q coulomb placed at the center of the hexagon is. Okay. So we have to find the magnitude of the force acting at the center where minus q charge is placed. So at this location minus q charge is placed. Since it is a regular hexagon, so the angle, this angle is 60 degree. Okay, this angle is 60 degree. So as all the angles are 60 degree and the side of regular hexagon are L, so all sides will be also L. Okay, and this will be like an equilateral triangle. Okay, if we are going to consider this one will be an equilateral triangle. Okay, having all angles 60 degree, having all angles 60 degree. That means this side length, this length will also be L, this length will also be L, this will be L, this will be L, this will be L, and this will be L. Okay, now let's talk about the electric field due to the charge at the center. So we know that the electric field due to this charge at the center can be given in this direction. Okay, so consider this electric field as E1. Okay, and E1 is equals to K into Q upon L square, where L is the distance between the center and this charge, and at center there is a point charge minus q coulomb. Now electric field due to this charge at the center will be in this direction, so consider this as E2. E2 is again equals to kq upon L square, because this length is also L. Now due to this charge, electric field at this location will be E3, and E3 is also equals to k into q upon L square, because this length is also L. Now due to this charge, Due to this charge, the electric field at the center will be in this direction, okay, uh, away at the center, because the charge nature of the charge at on all the vertices on the hexagon are positive. So this is E4, and E4 is also equals to kq upon L square, as this distance is also L, and due to this charge the electric field will be in this direction, so this will be E5, okay, and the magnitude will also be same. So we can see that E1, E2, E3, E4 and E5 all are equal in magnitude, okay. Now if we talk about the direction, E2 and E4 both are opposite in direction and same in magnitude. So E2 and E4 will cancel each other. So E2 and E4 will cancel each other. E3 and E5 both are equal in magnitude but opposite in direction. So E3 and E5 both will cancel each other. Now only electric field is present at the center is E1. So force on the charge, force on minus q charge placed at the center of hexagon, at the center of hexagon can be given as force equals to q into E. If we talk about the direction, since this charge is negative and electric field direction is towards left, so direction of force at the center will be towards right, okay. So this will be the direction of force because nature of the charge is left, nature of the charge is negative, okay, and direction of electric field is towards left, so direction of force acting on this charge will be towards right, okay. So force equals to q into E, and this can be given as q into electric field is kq upon L square. So magnitude of the force will be kq square upon L square, where k can be given as 1 upon 4 pi epsilon naught q square upon L square. So finally we can say that the force acting on the charge particle placed at the center of a hexagon is given as 1 upon 4 pi epsilon naught q square upon L square, and that is the answer of this problem. Thank you.